Water New Zealand has now published a code of practice for designing and operating fluoridation systems so that fluoride can be added to drinking water supplies in a way that is safe and effective. The code is endorsed by the Ministry of Health as representing good practice for the addition of fluoride to drinking water for the promotion of dental health. Hello, my name is Andrew Watson. I led the writing of the code on behalf of Water New Zealand and the Ministry of Health. I am a water supply engineer with experience in fluoridation in Queensland, Victoria and New Zealand. The code has been developed in consultation with our larger water suppliers who fluoridate, chemical and equipment suppliers and the public health team at the Ministry of Health. The code of practice therefore represents industry-endorsed practice for the safe and effective addition of fluoride to drinking water. Compliance with the new code is not a legal requirement, but like any industry code or standard, if it is not complied with and subsequently something goes wrong, for example, there is an equipment failure with resulting damage and/or harm to people, then the people involved in the design or operation of that system have very little defence in the eyes of the public and the law. The code applies to all new and upgraded water fluoridation plants after 1 January 2015. After 1 January 2020, that is in 5 years' time, existing water fluoridation plants will be expected to upgrade to comply with the code. Compliance with the code will show that the risks associated with fluoridation have been satisfactorily mitigated, and this can be documented in the supplier's water safety plan. For water supplies that include new or upgraded fluoridation plants, the drinking water assessors will be expecting to see this as part of their approval of the water safety plan. Both Water New Zealand and the Ministry of Health encourage water suppliers to comply with the code. Not only will it ensure the safety of consumers, but it will also provide increased public confidence in the practice of fluoridation. The aspects of fluoridation that are covered by the code are the regulatory framework, safety and design. That's making the design safer by incorporating safety into the design process right from the start. Requirements for the design and control of fluoridation facilities. Requirements for plant operation, including monitoring, training of personnel, occupational health and safety, security and environmental protection. Documentation, reporting and auditing. Fluoride dosing must be controlled within very tight limits so that the concentration of fluoride in the drinking water is at the optimum level of 0.7 to 1.0 milligrams per litre. A particular focus of the code is to make sure that this is achieved by setting out a number of functionality requirements. These include the incorporation of what are called independent checks on the amount of fluoride being dosed to minimise the risks of overdosing. For water supply systems that serve 10,000 people, at least 2 independent checks must be used. For systems serving 10,000 or fewer people, at least 1 independent check is required. I'm now going to step through each of the sections of the code. Section 2 covers the regulatory framework. In terms of the legislation, there is nothing that requires the addition of fluoride to a water supply. Fluoridation is undertaken by drinking water suppliers at their discretion. The Health Act requires drinking water suppliers to take all practicable steps to ensure they provide an adequate supply of drinking water that complies with the drinking water standards for New Zealand. Prepare and implement water safety plans. The drinking water standards for New Zealand sets a maximum acceptable value of 1.5 milligrams per litre for fluoride. A water safety plan requires a drinking water supply to consider the potential risks to the water supply and identify ways to manage these risks, and is therefore prepared for any problems that may arise. All size categories of water supply, except for small, which is 500 people or less, are required to prepare and implement approved water safety plans. Small suppliers may need to implement a water safety plan if that is their means of demonstrating that they are taking all practicable steps to comply. There are a number of other legislative requirements of relevance to fluoridation that are listed in the code. For example, the Hazardous Substances and New Organisms Act. In terms of roles and responsibility, for the Ministry of Health, its function is improving, promoting and protecting public health. Its role is to encourage drinking water suppliers to consider the use of fluoride to prevent and reduce tooth decay across the whole population, as well as to ensure that fluoride is added to drinking water in a safe and effective way. In terms of roles and responsibilities for water suppliers, for new and upgraded fluoridation plants, they should design, construct and operate the fluoridation plant in accordance with this code. Prior to the construction of a fluoridation plant, the supplier should have the design peer-reviewed against the code. When a drinking water supplier is implementing a new or upgraded water fluoridation plant, the drinking water assessor needs to be advised at the design phase, the construction phase, and immediately prior to introducing fluoride to the supply. The drinking water supplier is responsible for ensuring that the design, installation and operation of the plant and the storage and handling of the chemicals are in accordance with all the relevant legislative requirements. Section 3 of the Code covers safety and design. Safety and design is about assessing risks early in the design process to eliminate or minimise the risk to public health and the environment, and to ensure occupational health and safety throughout the life of the asset being designed. From April 2015, a new Health and Safety at Work Act will be introduced, and it will include safety and design requirements. The performance objective is to ensure the design, construction, installation, operation and maintenance of the fluoridation plant protects public health, protects the health and safety of those who will build and operate the plant, and that it does not cause environmental harm. Drinking water suppliers that are fluoridating or are planning on installing new plant to fluoridate must carry out and document a site-specific risk assessment covering all aspects of safety and environmental risk associated with the design and operation of the fluoridation plant. Where risks are identified, appropriate control measures based on the hierarchy of controls must be implemented. The preventive risk management system must include the development of considered and controlled responses to incidents and emergencies that can compromise the safety of fluoridating a drinking water supply, worker safety, or the environment. Based on the hierarchy of controls, hazards should be eliminated wherever practicable, followed by minimising the remaining hazards through use of engineering controls. The drinking water supplier should also conduct a hazard inoperability, a HAZOP study, as one part of the safety and design assessment. Section 4 of the Code covers the design of the fluoridation plant. The three chemicals used in the fluoridation of drinking water in New Zealand are fluorosilicic acid, sodium fluoride, and sodium fluorosilicate. The drinking water supplier is responsible for selecting the most suitable fluoridation chemical. The selection process should consider chemical availability and security of supply, whether a quality management system is in place to ensure chemical purity, and site constraints. Water New Zealand's Good Practice Guide, Supply of Fluoride for Use in Water Treatment 2014, should be used for specifying the supply of the chemical. The purpose of fluoridation is to adjust the fluoride content of drinking water to the optimum level of between 0.7 and 1.0 milligrams per litre to provide a dental health benefit. The selected target dosing concentration and the basis for the selection, including allowance for the fluoride concentration in the raw water, should be included in the water safety plan. Suppliers should maintain a historical record of the fluoride concentration in the raw water to ensure an appropriate allowance is made for fluoride concentration in determining the dosing concentration. The fluoridation plant must be designed to meet a number of functional requirements which are listed in the code. The key requirements are: operators must be able to monitor and control the fluoridation process reliably, accurately, and in a timely manner. The fluoride concentration must be at the selected target figure and controlled within the limits specified in the code. Fluoride dosing must be flow-based, based on a signal from the flow meter on the pipeline into which the fluoride is being dosed. The fluoridation plant must be configured so that the functionality requirements are fully automated and of dependable operation, with reliable stopping and starting of the system during plant shutdown and startup. The fluoridation plant must have alarms and automatic shutdowns for key process elements. The maximum physical dosing capacity of the fluoridation chemical feeding equipment must be limited by design to a maximum value that is as close as practicable to the operating target dose rate at the maximum water flow rate. Treated water exceeding a fluoride concentration of 1.5 milligrams per litre must not enter the water supply in the event of a failure of the control system. And finally, a set number of independent checks of the fluoride concentration are required. The independent checks must be truly independent of the system that is controlling the dosing of the fluoride chemical. They are required to minimise the risks of overdosing of fluoride. For water supplies that serve more than 10,000 people, at least 2 independent checks must be used. For water supplies serving 10,000 or fewer people, at least 1 independent check is required. There are 3 options to pick from for the independent checks. Independent check 1. Use of a day tank that can only be filled once a day and is equipped with an online device to measure its contents. A day tank acts as a physical barrier that minimises the risk of large quantities of chemicals being added to the water supply in error. Independent check 2. Use of a fluoride measuring flow meter on the fluoride dosing line before the dosing point. This check is only available for fluorosilicic acid or sodium fluoride from a saturator. Independent check 3. Use of an online fluoride analyzer on the drinking water line after the dosing point. Other design considerations included in the code are: no drinking water service within the plant or to consumers must be taken directly off the line to which the fluoride is dosed. The need for anti-siphonage, backflow prevention and pressure relief. It must be physically impossible for any component of the fluoridation feeding or control equipment to be manually plugged into standard electrical outlets for continuous operation. All key components of the fluoride dosing system must be interlocked to ensure total fluoride dosing system shutdown in the event of a failure of any individual equipment item, and to ensure that the dosing system cannot operate unless water is flowing. In terms of the chemical delivery, handling, storage, mixing and dosing, the code requires: 1. The supply of the fluoride chemical should be in accordance with the Water New Zealand Good Practice Guide supply of fluoride for use in water treatment. 2. For bulk chemical storages, there are a number of design considerations to be taken into account, including separation distances and bunding. 3. For powder chemicals, the design needs to minimise airborne dust and the need for manual handling. 4. Fluoride solutions should be homogeneous. Mechanical mixers should be used for the preparation of sodium fluorosilicate solutions. If using sodium fluoride, the fluoride plant should include a water softener where the total hardness of the water used for dissolving the sodium fluoride chemical exceeds 75 milligrams per litre as calcium carbonate. 6. Metering pumps must be able to accurately deliver the required flow rate and be sized to operate at maximum output during the maximum flow that the treatment plant is designed to operate at. 7. A safe method for calibrating dose rates must be available and maintained to ensure that the metering pumps are providing an accurate flow rate. 8. Dry feeder systems must ensure accurate delivery of the required volume or weight of fluoridation chemical for the quantity of water being treated and must be sized for the maximum flow of the treatment plant. 9. The location and detailing of the chemical injection point must provide homogeneous mixing before the first takeoff or sampling point, minimise loss of fluoride by dosing after the filtration step and as far away as practicable after the final pH correction if using lime, minimise the possibility of siphonage and overfeeding, be located upstream of buffer storage of treated water, not allow any bypass or secondary pipework into which the fluoride chemical will not be dosed, and consider the impact of any recycle streams to avoid double dosing. In terms of controls and alarms, the code requires: all dosing systems must be configured so as to be fail-safe, automatically leading to the cessation of dosing and generation of an alarm. Dosing must not restart automatically without manual on-site intervention. Where automatic shutdown systems can be manually overridden, such as for maintenance purposes, any override events must be logged and the override facility configured such that the operator is aware that the override is activated. The operation of shutdown systems must be fully tested at least annually and the outcome of these tests recorded. The final design requirement is in relation to security. Access to the fluoridation plant must be controlled to prevent unauthorised access through provision of a security locking system and signage. Section 5 of the Code covers operation and maintenance. In order that the plant and equipment used for adding fluoride operates in a safe, reliable and precise manner, the Code sets out a number of requirements. Ensuring that the plant and equipment is well maintained. Undertaking operational monitoring, looking at the gross quantity of chemical air used each day, and verification monitoring, treated water grab sampling. A quality management system to ensure the fluoridation process is adequately monitored and maintained, such that any discrepancy, equipment reliability issue, or unacceptable variability in the final fluoride concentration is readily identified and effectively rectified. Carrying out monthly plant inspections. Maintaining and calibrating all equipment and instruments. Ensuring that the operational personnel are appropriately skilled and trained in the management and operation of the fluoridation plant, and that these competencies are maintained. Managing occupational risks associated with fluoridation systems. The Code lists a number of health and safety measures, including personal protective equipment. Ensuring that the fluoridation plant is operated to minimise the risk of fluoride chemical spills or leaks, and that there are operating procedures for managing spills and leaks. Section 6 of the Code covers documentation. There are a number of documentation requirements listed in the Code. 1. Design report, documentation of the design of new or upgraded facilities. 2. Operation and maintenance manual. It must contain sufficient information to facilitate the operation and maintenance of the fluoridation plant by the operational staff. 3. Emergency management plan, to manage incidents and emergencies including fluoride overdosing, spills entering the environment and operator exposure. 4. Commissioning records, verifying that the fluoridation plant installation is in accordance with the plans and specifications and its operation is safe and reliable. 5. Record keeping, verifying that the fluoridation plant is managed and operated in accordance with this Code. In summary, the new Code of Practice for Fluoridation is a comprehensive document which represents industry-endorsed practice for the safe and effective addition of fluoride to drinking water. Both Water New Zealand and the Ministry of Health encourage water suppliers to comply with the Code, to protect the safety of consumers and to also provide increased public confidence in the practice of fluoridation.